Welcome back, Oleg is here. In the previous video we covered the basic definition of a function and 3 ways to define a single specific function. Today we are going to cover simple elementary functions, which are basically the simplest building blocks for the real existing functions which you all deal with, and then we will discuss what are the main classes of elementary functions. So let's begin with the first simple elementary function. The first one would be a constant function, which is also denoted as f of x equals to c. Capital C stands for constant. And an example of this function may be, for example, f equals to 5. So what does this mean? That regardless of x, regardless of the changes of the independent variable x, the value of the function dependent variable f, the value will be 5 always. For example, a real example of such a function may be a tax rate. Like in some companies, in some countries, this is independent on your income. This will be constant regardless of how much money you make. The next one would be the power function, which is x to the power of alpha, where alpha is any number, basically. So this may be positive, negative, it may be a fraction, for example, x squared, x to the power of -1, x to the power of 1/2, which is a square root, so this may be any. And another similar simple elementary function is the exponential function, but this is not the same. So this is alpha to the power of x, and it has 2 limitations. Alpha has to be positive and not equal to 1. Why? Because when alpha is negative, for example, -1 to some power, this will probably produce complex numbers, which is a problem for calculation, not problem but difficulty. And not equal to 1, because 1 to any power will be 1, so that's why it's not like an exponential function. So it may be really different, for example, 2 to the power of x. An interesting example of 2 to the power of x will be, for example, exponential growth of population. So let's assume that we have some cell which can be divided into 2 cells, or which divides into 2 cells every day, and each corresponding cell divides into 2 cells as well. So we can try to calculate the number of cells all together, regardless of the day. So the day 0, we have 1 cell to the 2 to the power of 0 is 1. At day 1 afterwards, this will be 2. 2 to the power of 1 is 2. To the power of 2 will be 4, and so on. So on the 10th day, we'll have like 1,000 population of 1,000 cells. Important to note that exponential and and power functions are not the same. The next one is logarithmic. So this is noted as log of alpha, which is basis or base of x. The limitations to alpha are the same. What does logarithm mean? The logarithm means what number should we take to get x? Like what power do we have to put alpha to get x? For example, like what power do we have to put 2 into to get 8? And this will be noted as log of 2 of base 2 to get 8. This will be 3, of course. An interesting note or highlight is that the logarithm with the base of e, I will cover later what e means and what it is equal to, is usually named as ln. And depending on the area you are dealing with, the logarithm with the basis of 10 sometimes may be named as lg. But in computer science, sometimes the logarithm with the base of 2 is called LG, so keep in mind and be careful when reading logarithms to with respect where you read about them. The next simple elementary function is a set of trigonometric functions. Simple examples are sine, cosine, and I have depicted them just for example to not spend your time on this. So this is an example of two functions. Red one is sine, blue one is cosine. You may be questioning why do we have so weird numbers on the x-axis. It's nothing more than just the values of pi. So the pi is just a letter to name the number of 3.1459, something like that, and so on. So 2 pi is 2 times 3.1459, and so on. So you can see that these are periodic functions with some shift between each other. So they have the same values, but with some shift between both, and they are limited with the amplitude of 1 both. But this may be, for example, scaled. If we say 2 multiplied by cosine, then the cosine will be a bit higher, like 2 times higher. So these are the periodic functions. And there are also inverse periodic functions and inverse trigonometric functions like arccosine, arcsine, arctangent, and so on. This doesn't matter for today's video, but generally you have to know that these are basically all the simple elementary functions. Let's move on now to the elementary functions. Elementary functions are obtained using simple elementary functions with some basic algebraic operations, addition, subtraction, multiplication, and division. It's important to know that there is a finite number of these operations and some combinations of these functions. For example, cosine of sine of x is a combination of two trigonometric functions, and this is an elementary function. Elementary functions are split into two main groups of algebraic and transcendental, and algebraic also has several subgroups, and we will start from the very internal one, from the very inside, and we will start from the whole rational function, which is depicted as this frightening formula. But let me also add some constraints, and also at the same time I will add an example and then describe what this means. So I think this example may be way more friendly to you than this complex general formula, but this means nothing more than a polynomial. It's also called a polynomial function, like whole rational function. The other name of it is polynomial function. This is a sum of x to each power from 0, x to the power of 0 to the x to the power of m, with coefficients a. These are just real numbers, where alpha or a0 is not equal to 0, so this larger coefficient, larger member has to be set, not 0. And this states the power of the polynomial. Like this polynomial function, this example, for example, is the polynomial function of degree 3. So this means that a0 is 1 and m equals 3, so this is the power. For example, a1 is 0, so we don't have the x to the power of m minus 1, so we don't have x squared. And a2 equals to minus 4, because x to the power m minus 2 equals to, is taken with a coefficient minus 1. And finally, am, which is the fourth coefficient, is just 1, because x to the power of 0 is taken just once. So this is the whole rational function, aka a polynomial function, which is a widely known and widely covered during the school times. For example, I'm sure that you have solved like some polynomial equations. Let's say that the quadratic polynomial equation, which is x squared plus something x plus some, I don't know, 1 equals to 0 and so on. This is covered during school times. So this is the rational part, this is the whole rational part, but there is also the fractional part, which is similar to the whole, but of course contains some fractions. So let me take an example. So this may sound and look even more frightening, but this is nothing more than just two polynomials, the one divided by the other. So this is just like a fraction of two polynomials, one above and one below. An example may be this. So just two polynomial functions, one of degree 2 and one of degree 3. So these both polynomial and fractional rational functions, this is fractional rational function, this is polynomial function, they both belong to the class of rational functions. The opposite, of course, to the rational function is the irrational one. So let me depict this one. So the irrational ones are quite simply defined as functions which contain the argument x under the root sign. So for example, this is a radical sign. These are just two examples, so let me try to come up with a couple more. For example, this may be f to some complicated polynomial, x to the x cubed, x squared, and so on and so forth. But it's important to know that if the argument is not under the root, but root still exists, for example, root of 2 times x, so root ends here, this is not an irrational function because x, which is our argument, is not under the root sign or radical sign. Only 2, which is a constant, is under the root sign. So this is not an example of irrational function, but these are really examples of irrational functions. So these are just the functions which are obtained over a limited number of operations, as all elementary functions, over power functions with like any powers, like this is like the altogether under the power of 1/2, which is a root square, and so on. These both rational and irrational, they form the class of algebraic functions. So all the functions which I have covered from rational and irrational, they're all algebraic functions together. And basically all the functions which are not algebraic, they will be transcendental. For example, e to the power of x. It doesn't have any root, but at the same time it cannot be represented as a polynomial function or a fraction of something. So that's why it's something different. It's something called a transcendental function. By the way, the other transcendental functions also, a good example of it is trigonometric functions. So at the same time being the simplest elementary functions, they are transcendental. So these are like not two classifications, so all the elementary functions have classification, and these are the simple elementary functions. They do not have a classification, they just have like a list of function types, if you wish. And for example, all the other combinations of such transcendental functions, like for example a cosine of e, or maybe, I don't know, like sine of cosine, and so on and so forth, they also will be transcendental. So today we've covered the simplest elementary functions and the classification of elementary functions, which contains algebraic and transcendental functions, and algebraic at the same time are split into rational and irrational functions, and rational are split into polynomial and fractional ones. So all of them are widely happening, and all of them probably something to be analyzed in the future videos. Thank you for watching.